Ancient DNA from 2,000-year-old mummies has been recovered thanks to their head lice. Now, when we go to archaeological museums, we see various lice combs. Those are the combs that they had made from ivory, and they had very, very small teeth on the combs, and they were obviously used for cleaning the head of hair lice. Parasites created cement, which preserves their clues. This is on WND from study finds. Scientists are thanking the cement coming from head lice for preserving DNA samples from 2,000 years ago. An international team says this substance encased ancient hairs from pre-Columbian mummies, preserving their DNA like a bug trapped in amber. The team explains that head lice use this cement, quote unquote, to essentially glue their eggs and their nits to the hair and scalp of people. Researchers found that even after 1,500 to 2,000 years, the knit cement kept the ancient humans' DNA in better condition than samples coming from other fossils such as teeth and bone fragments. Their findings are providing new insight into the migration of pre-Columbian humans within South America. Dr. Alejandra Perotti, Associate Professor of Invertebrate Biology at University of Reading in the UK, said in the release, like the fictional story of mosquitoes encased in amber in the film Jurassic Park, carrying the DNA of the dinosaur host, we have shown that our genetic information can be preserved by the sticky substance produced by head lice on our hair. In addition to genetics, lice biology can provide valuable clues about how people lived and died thousands of years ago, she said. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box. This is the one of the mummies of Argentina, a 2,000-year-old mummy of a male. Now, this is what an example of what they found the human lice, the head lice in. Typically, the scientists extract the DNA from the ancient humans from dense bone fragments or of the skull or inside the teeth. Until now, they've provided the best quality DNA samples for research. But in this case, researchers collected the DNA from the knit cement from 3 mummified bodies from Argentina. These people reached the Andes Mountains in central west Argentina between 1,500 and 2,000 years ago. The study authors found even more knits on a textile from Chile and a shrunken head from the ancient Jivaroan people of Amazonian Ecuador. The teams found that these DNA samples carry the same concentration of DNA as a human tooth and twice as much as ancient bone fragments. So you can see how successful the DNA recovery was here. The Dr. Mikkel Winther Pedersen from Globe Institute, University of Copenhagen, said the high amount of DNA yield from these knit cements really came as a surprise to us, and it's striking to me that such small amounts could still give us all the information about who these people were and how the lice related to their lice species, but also giving us hints to possible viral diseases. The knits died in the cold mountain trek. A review of the DNA revealed the first ever link between the mummies and humans in Amazonia 2,000 years ago. It's the first time researchers have found evidence that humans in the San Juan province migrated from the Amazon rainforest in modern-day Venezuela and Colombia. The team also found evidence of the Merkel cell polymavirus in the DNA, and this virus, officially discovered in 2008, is shed by healthy human skin. On rare occasions, the virus gets into the body and may cause skin cancer as well. These new findings point to the possibility that head lice may also help spread this virus. So as for the knits themselves, the team says it's likely these eggs died in the extremely cold temperature in the Andes. Researchers found small gaps between the knits and the mummy scalps along the hair follicles. Usually lice glue their eggs closer to the scalp to keep them warm. The findings are published in the journal Molecular Biology and Evolution. Please leave your comments, and thank you for your support.